July 30. It's 7:20 in the evening. So I'm going to switch over to using the inverter and battery to power up the house tonight. One aircon running. So I'm just gonna switch over at the main panel to the inverter. So I'm turning off the main panel from Isabela and then turn the inverter on here. Now the inverter and battery is running the household. So the battery is at 25.4 loaded. Load is 16%. The steady state of the house is 467 VA, 363 watts. So there's several fans, so running. That's the reason why the power factor has changed the VA, and it's drawing 16 amps. So the inverter will draw 16 amps and to provide 230 at those watts in VA. So I'm going to turn on the aircon and we'll look at the load. Now the load is at 30% or 32%. The VA now is 800 VA. And 793 watts. So the battery is or the inverter is taking 34 amps to generate those power to provide energy. So I'll let it run until the battery depletes. It has a automatic power shutdown. Once it reaches 22 volts at the battery, it will automatically turn on. So, yeah, we'll see what happens in the morning. I just don't know what time I'll trigger this power shutdown. It's 11:50. Finally the inverter battery depleted. So it's about, in this case, started at 7:30. It's 11. So it's 3 hours. Or yeah, 3 hours. Something like that. Too tired. I was sleeping. It's July 1st. So the test from last night lasted till 11 o'clock. So the inverter and battery energized the house for 3.5 hours at 900 VA. So from last calculation, that's basically 3.5 hours. So that's calculation and expected duration of the test match. So as the battery ages, the capacity also age. So instead of 150 amp hour, it's probably like it decreases. I don't know how much it will decrease, but it will decrease. So now the battery is charging. Today is overcast, but it's sunny, somewhat, a little bit. Hopefully the clouds will clear up and it put a lot of charge into the battery. So this is the situation. So here, 13 amps, 25 volts. So we're getting over 300 watts. So this actually derates the 1000 watt per square meters. So you're expecting 300 watts. You're not getting 300 watts. For example, if the panel is 300 watts. So with combined 1200 watts up of the roof, we're getting about 25% efficiency. So we're extracting the energy from the sun at 25%. So this is something to keep in mind. One has to derate the solar panel. Don't expect it to give you 1200 watts. Derate that depending on the solar panel extraction of energy, like 25% efficiency, 15, 16, 20%. So my suggestion is look for panel that has high efficiency, like 26%. That will serve its purpose over time. Anyway, they're a little bit more expensive, so something to factor in. Thanks for watching.